The person who invented the differential? Honestly, a straight-up genius. Because without it, every time you turned a corner, your car would be fighting itself. Here's the thing. When your car makes a turn, the inside wheel takes the short route. The outside wheel? It has to swing around a much wider arc. Same amount of time, more ground to cover. That means the outside wheel has to spin faster. Now imagine both wheels are locked at the same speed. The tires start scraping. The car feels like it's fighting you. And in the worst case, the axle actually snaps. The differential fixes all of that. Elegantly, completely. It lets each wheel spin at its own speed, exactly when it needs to. So how does it actually work? Let's break it down from scratch. No engineering degree required. Picture the two rear wheels of a car, each sitting on its own axle. Now attach some spokes to each axle. Spin the spokes, spin the wheels. Simple. Now connect both axles with a crossbar. Spin the crossbar, both wheels move together, same speed, same direction. Great for going straight. Useless for turning. So what if that crossbar connection could rotate? Now if one wheel slows down or stops, the other one keeps going. Progress. But here's the catch. Now the crossbar just flops around. It loses the ability to actually drive the wheels. The fix? Add more crossbars. Add more spokes. Now when one wheel stops, the system keeps pushing power to the other wheel. No flopping, no slipping. And as you keep adding spokes to smooth out the gaps, you've basically just invented the gear. Yeah, that's all a gear really is. Now let's look at the real thing. The entire differential is sealed inside a tough metal housing. That casing keeps dirt and rocks out and locks the lubricating oil in, so the gears stay smooth and don't grind themselves to death. Power comes in from the engine through a small pinion gear. Notice those gears aren't straight cut, they're spiral. And that's intentional. Spiral cutting means more tooth contact at any given moment, which means stronger, smoother power transfer. That pinion drives a large ring gear, and attached to that ring gear are the planet gears, usually two of them, sitting directly across from each other. They spin with the ring gear, but they can also spin on their own little axis. Sound familiar? That's our crossbar. Those planet gears then mesh with the two side gears, one connected to the left wheel, one to the right. Those are our spokes. Driving in a straight line, both wheels push back with equal force. The planet gears don't need to spin on their own axis. Power flows evenly to both sides. Clean, smooth, straight. Now take a left turn. The right wheel has to cover more ground, so it speeds up. That causes the planet gears to start spinning on their own axis. The left wheel slows down to compensate. The speed difference between the two sides is perfectly balanced, inversely proportional, automatically, with no input from the driver. That's the open differential, and it's brilliant. But, and there's always a but, the open differential has one real weakness. It always sends power to the path of least resistance. The easiest wheel to spin gets all the torque. So if you're stuck on ice, or one wheel is sitting in mud, that wheel just spins helplessly while the other one sits there doing nothing, and you're going nowhere. That's why modern vehicles add a limited slip differential, or a differential lock, to keep power going where it's actually needed. But that's a story for another time.